In this lesson, we're going to be talking about something that goes along with air conditioning in a lot of environments, and that's electric heat. Okay, electric heat installation is less complicated to install than most other types of heating. The only connection required is the electrical wiring, the thermostat control, and the air ducts. Now, the heating is typical in areas where cooling load is predominant. In other words, areas in the southern part of the country where you don't have to have a lot of heating, but we do a lot of cooling. It's very common to find electric heats used along with cooling units, especially heat pump. Unlike a standalone electric furnace, most air handlers can be adapted for both electric heating elements and cooling coils. In this way, the same air distribution system can be used for heating and cooling modes. The installation of a warm air electric furnace requires a few preliminary considerations. First, it should be located in an area that will provide for proper clearance from combustible materials and has good support. The plenum connection, that's the ductwork connection, should be adjusted to fit properly and sealed to prevent air leaks. Electric furnace installation is flexible. It can almost be installed anywhere within a building. I don't need to have vent connectors. I do not have to have piping for fossil fuels such as oil and gas. Electric furnaces also weigh a lot less than fossil fuel burning equipment and therefore require a little bit less support. Most electric furnaces are multi-positional, so they can be installed in many different directions of airflow. They can be installed in the upflow, downflow, and horizontal positions without modifying the unit. For furnace support in slab and on grade and basement installations, the furnace would typically rest on a return air box called a plenum. Return air boxes are typically made out of sheet metal or, in worst case scenarios, ductboard. Okay, this is an electric furnace heat pump on a slab. Okay, we have the return air plenum at the bottom. We have our refrigeration line set. We have the return air ductwork. We have supply air ductwork, and we have the electrical wiring for the electrical heat. In crawl space installations, the furnace is suspended from the joists. In an attic installation, the furnace can be suspended from the roof joists or placed on the roof joists with proper support and material. Without proper material, the furnace noise will amplify and become a nuisance to the homeowner. Little noises amplify really hot in overnight hours, okay? A little click when the house is quiet and everyone is trying to sleep sounds like someone banging on the ductwork, so you got to be very cautious about noise. This is an example of a crawl space installation. Again, remember we said it can be suspended. You still have your condensate lines. And this is a horizontal installation, but it's not on the dirt floor of the crawl space. An attic installation always requires an overflow drain pan with an emergency overflow. And the reason for this is so that if the condensate gets clogged up here, it will go into the drain pan and won't destroy the ceilings. Notice how the ductwork has mastic on it, and everything has been sealed, even around the refrigeration line, so there's no air leakage. For furnace clearances, you'll always want to refer to the manufacturer's literature and appropriate code to determine furnace clearances. Furnace clearance minimums are the minimum distance from each of the furnace surfaces to any combustible material. The manufacturer's literature and/or local codes will provide these distances. Not all furnaces have the same minimum clearances. They're all different. Some furnaces may rest directly on a piece of plywood with zero clearance, but the front may require 24 inches or more for service. Ideally, the service clearance should be at least 36 inches so that a service tech can get in and remove doors and remove components and clean and replace components. For plenum connectors, there's a 3/4 inch flange on the furnace supply and return ducts. To protect the flange from being damaged during shipping and handling, some manufacturers leave the flange flat. On these furnaces, the technician will have to bend the flange 90 degrees outward so it can be used to attach the supply air plenum. The best tool for bending the flanges are hand seamers, sometimes called hand brakes. Duct connections may vary between furnace types as to whether they're upflow, downflow, or horizontal configuration. This is an illustration showing how to a reducer for connecting the furnace to the duct in an under the floor supply duct application. A duct opening would need to be cut out in the floor. The connector tabs would need to be bent over in order to fasten to the connector to the supply duct and then properly sealed to prevent leakage. Duct connections will vary depending on the application and the setup. Plenum sealing is required. To prevent air leakage, the supply and return plenums must be sealed with mastic. Mastic may be applied directly to the sheet metal of plenums, and you need to be careful when applying the mastic as the sheet metal has sharp edges and will cut you. Fiber tape must be used when the duct board or other materials are being used. Air leakage can also occur in the space in which the furnace is being installed if it's not mounted and sealed properly. To select a system, the furnace must be chosen with the heating capacity of at least equal to the heat loss of the room, area, or building to be heated. Electric furnaces are typically available in multiples of 17,000 BTUs per hour. Every kilowatt will produce 3,410 BTUs per hour. The heat strip used in most electric furnaces are rated at approximately 5 kW per strip when operated at 240 volts. So each 5K heat strip will put out about 17,050 BTUs per hour. The electric capacity must be considered when selecting electric heat because they use a large amount of current. An 84 kilowatt electric furnace may draw up to 84 amps. A typical modern residential service connection for electric heat has 150 to 200 amps, while older houses only have a service connection of 60 to 100 amps. In some cases, the home's electric service connection may need to be upgraded to install the electric furnace properly. The actual furnace voltage that the imported will be operating at is also important. Most electric furnaces run at voltages less than 240 volts. There's a significant loss of heat capacity when the furnaces are installed in lower voltage supplies. This is an example of an electric furnace specification. Okay. The KWs are rated the second line of blue near the top. So we have 5 kW, 2 heat strips is 10 kW, 3 heat strips is 15 kW, and 4 heat strips is 20 kW. At 208 volts, each heat strip is 3.7 kW. Okay, and then it also gives you the BTU equivalents of that. The most important part of an electric furnace installation is sizing the power wiring. Due to the excessive current draw of electric elements, the power wiring is critical. The number of the conductors need to be sized using the wiring size table in accordance with the NEC or National Electrical Code, and it has to handle the minimum circuit amperage listed on the unit data plate. The unit data plate will give you the wire diagram, it will give you the fuse information, and it will tell you copper wire only. Sometimes the use of aluminum conductors can save on the installation cost because large gauge wires can be expensive. However, make sure you check with the manufacturer warning labels. Aluminum wire in many cases does not stand up to the heat generated by the large current draws. If no guidance as to what type of wire can be used on an appliance, the installer must check to see if the connections on the furnace are designed for aluminum or copper. Typically, the connectors are labeled or marked with CU/AL if both copper and aluminum wires are acceptable. If copper can only be used, the lugs are marked CU only. CU is the symbol for copper. The copper and aluminum wire lug is on the left. Copper only usage. It's not a clear image, but it's basically on the right. Look for the designations on the wiring. Aluminum conductors require application of an antioxidant paste to prevent a poor connection, which will result in oxidation. So if you use aluminum conductors, you have to use a paste that goes along with it. The furnace has to be protected with a circuit breaker no larger than the maximum rating on the data plate. There should also be a disconnect switch located within line of sight of the furnace that's at 115% of the units of maximum circuit amperage. Control wiring has to be done with 18 gauge solid copper wire. Typically, mechanical heating only thermostats will have just two connections. One connection for the 24-volt transformer, one connection for the furnace controls. With only two wires, it really does not matter which of the control terminals the wires are connected to because it's just a switch. Some systems may have a third wire to control the fan. With three wires, the connections do matter. Some digital thermostats require a common wire for the transformer from the transformer to operate. So the furnace terminals, the thermostat terminals, and the suggested wire colors. More and more, you're going to find that it just matters that the same wire colors used on the furnace terminals are as it is on the thermostat terminal. R is your 24-volt power. W is your heating signal. G is your fan signal. And C is used only for digital thermostats, but it comes back to the common side of the transformer. So with electric heating, you can basically install the furnaces in many different places. No fuel lines are necessary. No venting is necessary. Your biggest issue is the electrical installation. Has to be done in accordance with the NEC 70 National Electrical Code. And you have to make sure that the building's power supply can handle the additional amperage caused by the electric furnace.